Good evening everyone. This is the third part of video, that is motion in a straight line. Okay. First of all, I welcome you all in a Sapiens Education. For more information, you please visit www.sapienseducation.com. So motion in a straight lines. There are three topics today I will be covering in this part. That is velocity time graph, discussion on a velocity time graph, then I will analyze the velocity time graph, and then I will derive all the three equations of a motion by using derivative method. So first of all, I will discuss about velocity time graph. Okay, now let us consider a velocity time graph. As I have already discussed about distance time graph, now today I am going to discuss about velocity time graph. Okay, velocity time graph. Let us consider y-axis as a velocity and x-axis as a time. Okay, if y-axis as a velocity and x-axis as a time, then how I will do this? Let us do this. Let us take this. Okay, this is your velocity and its unit is meter per second, and this axis is time, which is in a second. Okay, now let us consider a graph like this, and this is your graph. Okay, suppose an object's position velocity time graph is showing like this. Okay, so what does this means? What does this means? See, for 0 second, for time equal to 1 second, for time equal to 2 second, for time equal to 3 second, for time equal to 5 second, for time equal to 6, 7 second. What is the velocity? See here, 1, 2, 3 meter per second. It may be a 4 meter per second. It may be a 5 meter per second. From figure you can see that up to 7 second velocity remain constant, that is 4 meter per second. Okay, so whenever you see the graph where in a velocity time graph, if the slope is like this, then you can say that velocity is constant. So our conclusion is that velocity is constant. Okay, velocity is constant. Okay, now tell me, what does slope of velocity time graph indicates? So let us consider another graph. Before that, I will tell you that velocity is constant. So motion is here. Motion is uniform. Motion is uniform. Okay, motion is uniform. Understood? So acceleration will be 0. Acceleration will be 0 because velocity is constant. Now I will discuss another graph of same velocity time graph. Okay, velocity time graph, but the slope will be little bit different. See here, slope will be like this. So if the velocity is here like this, time is this, so what we get the conclusion? See here, for example, time is 0 second, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, and so on. Velocity in meter per second will be 1 second, 2 second, 3 second, 4 second, 4 meter per second, 5 meter per second, 6 meter per second. So in each and every second we see conclusion we can draw from velocity time graph is that velocity is changing with the time. Velocity is changing with time. Okay, so either there will be an acceleration or deceleration. So we can say that motion is accelerated. Motion is accelerated. Okay, now what does slope indicates? So as you know that slope is what? See, slope means what? See here, whenever I want to find a slope like this, so suppose there is A, B and C, slope will be equal to what? Slope will be equal to BC by AC. What does BC inverse? BC is your velocity. This physical quantity is BC physical. Which physical quantity is shown by BC? That is velocity. And AC, the physical quantity shown by this AC is your time. Okay, so BC by velocity by time. So velocity by time is your acceleration. So what type of conclusion we have drawn? Slope of velocity time graph. Slope of velocity time graph indicates acceleration. Okay, understood? Now, so there may be a different type of slope. So we will discuss about different type of slope. So we have already find out the conclusion that the slope of velocity time graph indicates velocity. Now one more thing, what does the area under velocity, what does area under velocity time graph, area under curve of velocity time graph indicates. So let us consider a velocity time graph. So this is your velocity and this is your time, and there is a curve like this. Okay, so velocity you can write 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, and so on, 5 meter per second. So its unit is meter per second, and time unit is second. Okay, so this may be a 1 second, 2 second, 3 second, 4 second, 5 second, 6 seconds, and so on. Okay, now I want to find area under curve. So you know that this is your curve. Okay, where curve may be a straight line, curve may be like this, it doesn't matter. So we need to find area under this curve. So let us consider this area under this curve will be like this. So red mark indicates the area under curve. So how you will find area under curve? Can you write here area under curve will be equal to area under curve equal to 1 by 2 into base of triangle, or you can simply write that area under curve equal to O, A, and this is your B. Area under curve equal to area of triangle AOC. So this can be written as half into base into height of the triangle. Yes or no? Height. So base is indicated as what? Which physical quantity is indicated by base? So time. So you can write 1 by 2 into time. And what the physical quantity indicates this height. So this is your velocity. So velocity into time, velocity into t. So what does you infer? Velocity into time. Anything in which physical quantity will depict the velocity into time. So velocity into time is your distance actually. Okay, distance. Okay, so what type of conclusion you draw? Conclusion, tell me. Conclusion is that area under curve of velocity time graph indicates distance. Okay, so these things we have understood, these things you are able to understand. That one conclusion is that slope indicates acceleration, and area under this curve indicates distance. Okay, and the unit of distance is meter, distance in meter. Okay, or you can simply say that velocity time is there, so you can replace this distance by displacement also. Okay, displacement also. Okay, for displacement it may happens See here, one situation may occurs. One situation may occurs. Suppose a velocity time graph is like this. So this is positive displacement. This is your positive displacement, and this is your negative displacement. Okay, negative displacement. If you will add on, so total displacement will be 0. Total displacement will be 0. Okay, will be 0. So total displacement will be 0, but total distance travel cannot be 0. But total displacement, sorry, uh, total distance can't be 0. Can't be 0 because it is absolute quantity. Because it is an absolute quantity. Absolute quantity. Okay. So I hope you have understood this. Now I will analyze different type of curve, okay, of a velocity time graph. I will discuss about different type of curve of velocity time graph. So see, this is your velocity time graph, and curve is like this. Curve is like this. So this is your velocity and time graph. So from this curve, we can say that velocity is constant as slope is 0. Slope from this curve, you can easily say that slope, that is, it has no slope. Slope is 0 means what? Acceleration is equal to 0. If acceleration is 0 means what? Velocity is constant. Velocity is constant. Okay, and distance, if you want to find distance, how you will find distance? So you have to use area under this curve. So red region will be distance. Okay, this area is called distance. Area is distance. Okay, so this is what you will able to find out or draw the conclusion of velocity time graph. Now I will go for another type of graph in a velocity time graph. Another type of graph in a velocity time graph. Okay, so let us consider this is a velocity time graph. VT curve. Okay, so this may be like this velocity time graph. Okay, so slope is what? Slope is constant. Why constant? Because it has constant angle, so slope is not changing. Slope indicates, slope of velocity time graph indicates, slope of velocity time graph indicates just now I proved, indicates acceleration. Okay, so if slope is constant means what? Acceleration is constant. If acceleration is constant, then body is accelerated. Body is accelerated, rated, and it means that velocity is changing. Velocity is changing. Okay, see here in a figure also you can able to figure out that velocity is changing with time. See here, suppose this is 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 7 second, and this is your 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, so on. Okay, so you can figure out from figure that velocity is changing. Okay, but the motion is uniform. Why? But the motion is uniform. Why it is uniform motion? Is uniform. It is uniform because acceleration is constant. Acceleration is constant. That means it that means velocity is changing with velocity is changing with equal rate. Okay, equal rate. Understood? Now if you want to find area, then how you will find area? So you need to draw a curve on area under this curve. So if you have to find area under this curve, so this area will be equal to distance. So you have to do these things in numerical also. If you want to do numericals, then you will able to understand. Okay. Now again there will be a different there may be a different variety of a velocity time graph. See here, velocity time graph. Let us consider this as a velocity time graph. So it may be like this. Okay, so from graph we can conclude that motion is non-uniform. Why this is your non-uniform, you should understand. See here, slope at every time slope is what? Increasing. Okay, slope is increasing. Okay, if slope is increasing means what? Acceleration is increasing. Acceleration is increasing. If acceleration is increasing, then your motion is what? Motion is non-uniform. Okay, and if you want to find distance, so distance will be area under this curve only. Okay, area under this curve. So if you will able to figure out this area, so this area will be equal to your distance. Okay, so if you want to find the distance, then you need to find area under this curve. Okay, I hope you have got a lots of information about velocity time graph and how to find area, how to find the distance, how to find the slope, which type of motion is it. Okay, I hope you understood all this thing. Okay, now I will discuss the next topic, that is equation of motion. Okay, I will do this equation of motion with derivation. Equation of motion derivation of equation of motion. Okay, now before this you need to know about few terms. Okay, let us, there is a body and it has u as a velocity. U is your initial velocity. Okay, and now after a certain time period, this body came at this place and its velocity become v. Okay, and the distance travel between initial and final point, this is your initial position and this is your final position. Okay, and the distance between these two position is s. So u is the initial velocity, v is your final velocity, b is final velocity, s is the distance traveled, your displacement. Okay, t is time taken. Suppose t is the time taken by object to move from initial to final. Okay, so t is total time taken. Okay, time taken. Understood? So this thing you need to understand, that a object is at an initial position, that is a, and at a final position it is b. Its initial velocity is u, its final velocity is v, and its total distance travel is s, and total time taken is t, and body got accelerated. Suppose there is a force is applied on this body and its velocity changes, so there will be definitely an acceleration. A is your acceleration. Okay, so if a is your acceleration or constant acceleration. Okay, so with the constant acceleration, its velocity changes from initial u to final velocity v, and total distance traveled is s, and total time taken in moving from one initial point to final position is your t. Okay. Now, how to derive the equation of motion? So first of all, as you know that what is differentiation and what is integration. So I will use the differentiation and integration. So first of all, I will derive first equation of motion. First equation of motion. Okay, first equation of motion, how I will derive this. Okay, now tell me, acceleration is what? Acceleration is rate of change of velocity by dv by dt. Can we write this as a dt equal to dv? Now now integrate integrate both side. If you will integrate both the side, then what will happen? A dt will be equal to integration dv. Okay, now its initial velocity u is your its initial time is t. Its initial time will be 0 if its time start from 0 and final time is t, and if its initial velocity is u and its final velocity is v, then we need to integrate this. Okay, so by integrating, since I have told you that acceleration is constant, so acceleration will come out and integration of dt will be t, and it is from 0 to t. Okay, and integration of v is v, but this velocity is from u to v. Okay, so a t minus 0 it will be equal to v minus u, so at will be equal to v minus u. So finally we got an equation v equal to u plus at. Okay, if you will rearrange this equation, you will get this answer. So this is the equation of first equation of motion. I hope you have understood this. Okay, so by using this acceleration equal to dv by dt, and by using integrating both the side, and you have to give the limit, use the limit. Okay, use limit. Okay, use limit. By using limit, you will able to figure out what is the equation of motion. Now it is a term of second equation of motion. I hope you have understood this first equation of motion. Now I will prove second equation of motion. Okay, now this is your second equation of motion. How you will find out second equation of motion, or how you will able to derive second equation of motion. These formulas are very important while solving a problem. So let us consider a second of equation of motion. Can we write velocity is equal to rate of change of displacement by time? Can we write this? So can we write this equation as v dt equal to ds? Okay, we can write. Now as we know that v equal to u plus at, just now I have derived. Okay, just now I have derived. See, u plus at, just now I have derived v equal to u plus at. Can we put this v as u plus at here in the above equation? V equal to, if you will put v equal to u plus at, and you write this dt equal to ds. Can we integrate both the side? So please integrate both the side by putting limit. Limit means what? What is the range? Okay, by putting limit means what? See here, if I am putting a limit, it means I am putting a range. Range means what? See here, see here, you have seen that t equal to 0 to t equal to time t taken, so its limit t equal to time t is taken, so 0 to t is the limit. Distance, suppose distance x equal to 0 started, and final distance it has reached to s, so x equal to s is the final limit. So in this way we need to give a limit. Okay, so if you will give a limit, then only you will able to figure out the perfect formula. So integrating both the sides, what you will get, see here, u dt plus integration at dt equal to integration of ds. Okay, so now u dt, since it is a derivative of t, so its time start from 0 to t. Again here also time start from 0 to t, and distance from 0 to s. Okay, so u is your constant initial velocity into time is integration of dt is your t, and its limit start from 0 to t, plus acceleration is constant, so t dt, so t dt has a integration of t square by 2, and its time start from 0 to t, and this is equal to s, and its integration limit is 0 to s. Okay, so see here, if you will put the limit, then what will happen, u t minus 0 plus a t square minus t square by 2 minus 0 square by 2 equal to s minus 0. So finally you are getting answer ut plus 1 by 2 at square, and this is equal to s. So finally we have got second equation of motion, hence proved. Okay, this is your second equation of motion. So if you want to derive second equation of motion, so you have to use this method. Okay, so this is the derivative method. So this is a very easy method, you can derive easily. I hope you have understood this, how to derive it. Okay, now let us consider a third equation of motion. Okay, and derive it, third equation of motion. Okay, third equation of motion, motion. As we know that acceleration equal to dv by dt, can we write here dv by ds, just multiply or divide by ds divided by dt. See here, dt I have done here, dv I have put this, dt I put this, and ds make got cancel. So you can write a equal to dv by ds into ds by dt. Now can anyone tell me what is the meaning of ds by dt? Since dv by ds into ds by dt can be written as v, okay, and this is written as acceleration. Now rearrange the equation. So a ds, sorry, it's like 0, a ds can be is written as v dv. Okay, now integrate both the sides with limit, integrate both the side with limit. Okay, so by putting a limit, we can integrate this both the side. So what will happen if I will integrate both the sides? So please integrate this both the side. So if I will integrate this a ds, so it is respect to ds, so distance means 0, start from 0 and it reaches to s, and this is equal to v dv, v and dv. V velocity start from u initial velocity and end with the final velocity. So as you know that acceleration is constant, so this will come out ds, integration of ds will be s, and it is you can put the value 0 to s, integration of v dv. So v is integration of v dv will be v square by 2, and you put the limit u to v. So finally what you are getting, see here, as equal to v square minus u square by 2. Okay, so finally rearrange the equation. So if I will rearrange the equation, I am getting 2as equal to v square minus u square, and you can also furthermore rearrange v square equal to u square plus 2as, and this is the final equation, final third equation of motion, third equation of motion, and I have derived it with the help of derivation, okay, derivative using integration. I hope you have understood. So today we have what we have learned, or what I have taught you. I have taught you basic graphs. Today I have taught you, let us revise one by one. So today I have taught you velocity time graph, analysis velocity time graph, and what type of velocity time graphs are there. Again, area under the velocity time graph indicates distance, okay. So there may be a displacement, positive displacement, negative displacement. So what type of conclusion you can draw if graph is like this? What type of conclusion you can draw if graph is like this? What type of conclusion you can draw if graph is like this? So in this way you will able to understood, and you can go through this whatever I have taught you. And if you have any type of query, just contact to Sapiens Education. Thank you everyone for your patience, and hope I will discuss in next video. I will discuss a relative velocity. Hope you have enjoyed the session. Thanks everyone. Thank you.